In this video, I will be going to introduce the new concept which is called Runnable in LangChain. You might have seen the older codes which are written in LangChain. You might have seen llm.predict function or prompt.format function or parser.parse function. It will be like this: llm.predict function or prompt.format function or parser.parse function. Not like llm.invoke function which I have told you, or prompt.invoke function I told you, or parser.invoke function I told you. You know that prompt object is created from prompt template, or parser is created from string output parser or JSON output parsers. There are so many parsers. Those classes were not standardized earlier, but now these classes are standardized and we just need to use the invoke function only, not a different kind of function. Now, why do we need Runnable? For simple logic, non-standardized components were manageable. But for the complex logic, like if you want to build any if-else condition or you want to run multiple steps simultaneously or calling multiple LLMs, it became difficult to manage the non-standardized components. Here components means these are the objects of different classes. So those classes were non-standardized. Like I have told you, you were using predict function or format function. It was manageable for a simple task, but when the task become very complicated or very complex, then it became difficult to manage those tasks using the non-standardized objects. So to standardize them, the concept of runnable was introduced. One of the example of standardization is invoke function. So you remember when I used LLM object of chat OpenAI, I used llm.invoke. When I use the parser object of string output parser or JSON output parser, I use parser.invoke. And when I created a prompt from prompt template, then also I used template.invoke, not template.format. So you see, this is standardization, and this standardization is achieved with the help of Runnable. So what is actually Runnable? Runnable is a base abstract class. What other classes do, they inherit this Runnable class. This Runnable base abstract class, they inherit so that this class become standardized. So you see, all the classes like prompt template class or string output parser class or chat OpenAI class, all these classes have inherited this base abstract class to make them standardized. So that is why you were able to use prompt.invoke or llm.invoke or parser.invoke. Because those classes were standardized, that is why you were able to use the chains. I have already shown you the chain concept where you see template was passed to the LLM and through LLM it was passed to the parser. So this kind of chain I have created. So these chains are possible because these are the objects of runnable class and those classes are standardized. Otherwise, you will not be able to use chaining like that. Now I will tell you there are different types of runnable. Number one, it is task specific runnables, which I have already told you, and there are runnable primitives. So now what are task specific runnables? These are the classes which are converted into runnable. So you are taking a class which is inheriting the runnable class, and those classes are getting standardized. So you know these examples which I have already discussed, like chat OpenAI, prompt template and string output parser. These are the task specific runnables. Then you have runnable primitives. Now these do not perform any AI task directly, but they can control the programming logic. Like it can do chaining, Like the chain, I have already shown you how to build. It can do branching, it can do parallel execution. So all these concepts I will explain you. So these runnable primitives are used to build the logic, like branching, making if else conditions, performing parallel executions, etc. So inside these logic, you can place task specific runnables. So what happens is runnable primitives will be used to build the logic, and inside those logic you can put your task specific runnables, which are the objects of chat OpenAI or prompt template or string output parser, etc. And those task specific runnables will perform the actual task. So I hope you understand this point. Runnable primitives are used to build the logic, and task specific runnable will perform some task. So the examples of runnable primitives are runnable sequence, runnable parallel, runnable branch, runnable lambda, runnable pass-through. So all these runnables I will be going to discuss with you in next videos.